Hi, um, I'm Vishnu Devneni, and my teammates are Bharat Kondedi and Vaishnavi. Today, we're going to discuss about our project, which is emotion recognition using artificial intelligence. We have used two deep learning models, which are lstm and CNN. Firstly, human facial expressions can be easily classified into seven basic emotions, which are angry, sad, surprise, fear, happy, and neutral. First, we have taken two deep learning models, that is CNN and LSTM. We want to try which model is better and which has high accuracy. So we have started finding the accuracy of them. So I'm going to show you how we have implemented the model. First, here we have imported all the libraries which we want. Those are NumPy, Pandas, OS, and also TensorFlow, Keras. And here we have mounted our Google Drive so that we have got the data set uploaded into our drive, which is 28,000 images for a trained data set and 8,000 images for a test data set. These all data sets are classified into seven classes. Those are all the human expressions which I have shown earlier. And later on, we have connected our drive, and later here we got the data set and we imported the data set into the collab. So as you can see here, how many classes are there and what are the inputs what are the inputs and how many images are under which class. So this is a bar graph which shows all the images which are there in the data set, and this is a trained data set, this is a test data set. uh, coming to this we have we have created to compress the file to 48 by 48 pixel, and also we are converting all the images to the grayscale. And here, as you can see, there are 28,709 trained data. The dataset contains 28,709 images in the training data and 7,178 images in the test data. So as we said, we have created all different classes in different files. So you can observe that here. And now defining the model. This code defines several callback functions that we'll be using during the training of a deep learning model. Early stopping is a callback that will stop the training process early if the chosen metric stops improving for a certain number of epochs. In this case, it will start training if the validation loss does not improve after 3 epochs. The TensorBoard is a callback that will write logs that can be visualized with TensorBoard. TensorBoard is a tool that can be used to visualize metrics and other information about a model during training. Generally, CNN is a convolutional neural network, which is a deep learning algorithm commonly used for image recognition and classification tasks. The network consists of multiple layers of convolutional and pooling operations, followed by one or more fully connected layers. Convolutional layers apply filters to the input images to extract features, while pooling layers reduce the dimensionality of the feature maps. So, yeah, coming to this, the summary shows that the convolutional neural network, it consists of 4 convolution layers, which increasing number of filters, followed by max pooling layers, batch normalization layers, and drop output layers to prevent overfitting. The output of the fourth convolutional layer is flattened and passed through 2 fully connected layers with dropout and batch normalization. The final output layer consists of 7 neurons corresponding to 7 emotion classes. The number of trainable parameters in the model is 4,000, sorry, it's 4,496,903, as you can see here. Later, we have developed a Keras plot model so that you can see the chart here for our neural networks. And here we go. We check the model here, and we have trained the model based on the size 48 by 48 pixel, and we have reshaped, even though the data has a different pixel, we have reshaped it to a 48 by 48 pixel, and later we have set the batch size as 64, and we have given 30 epochs for this model, and the steps per epoch is 50, and finally we got an accuracy of 59.26. And now Vaishnavi will take off LSTM. She'll explain what is LSTM and what we did with the deep learning model.
So coming to the another model that we created is short-term memory. So here's all the code. Firstly, we import all the libraries that are required, same as CNN, all the TensorFlow, Matplotlib, Seaborn, everything like NumPy, CV2. And then we mount our drive to the Google Colab with the training and testing images again. And then coming to the count exp function that counts the number of images in each subdirectory of a given directory containing facial expression images and returns the count as a pandas data frame. Overall, the purpose of this code is to provide the summary of the number of images in each subdirectory of train and test directories. Coming to the next code, it defines two instances of image data generator class from Keras and train data generation and test data generation, which will be used to pre-process and augment the training and testing data respectively. Similarly, the test data and instance is configured to perform only rescaling of the testing images, and the test set object is created by calling the flow from directory method, and the test gen instance which generates the batches of testing data from a directory with same parameters as training set. The DCNN consists of multiple convolutional layers, each followed by batch normalization, activation, and max pooling. There are also several dropout layers to prevent the overfitting. This is a Python function that defines the convolutional bidirectional LSTM model for a given input shape and number of classes. The function first builds the deep convolutional network DCNN using the build DCCN function, which takes the input shape as a parameter and returns the DCNN that is wrapped as a time distributed layer. The output of this layer is fed to two bidirectional LSTM layers followed by two dropout layers. These bidirectional LSTM layers allow the model to consider past and future frames when processing the current frame. The dense layer with 128 neurons and ELU activation function followed by a batch normalization and a dropout layer is added to reduce overfitting. Finally, the model is terminated with a dense layer with a number of neurons equal to the number of classes and a soft max activation function to output class probabilities. The function returns the convolutional bidirectional LSTM model. If show@, parameter is set to true, it prints out the summary of the model of the architecture shown as in the figure. So after developing both the models, CNN and LSTM, they are both used for emotion detection tasks, but they have different strengths and weaknesses. CNN are good at processing image data because they can capture spatial information from the image and learn complex features. They are commonly used in computer vision tasks, including emotion detection from images. LSTMs are good at processing sequential data because they can capture temporal dependencies and learn from the sequence of inputs. They're commonly used in natural language processing tasks, including emotion detection from text. So if you're working with image data, CNN may be better choice for emotion detection, while if you're working with the text data, LSTMs may be suitable. However, the best approach ultimately depends on the specifiers of your task and the nature of your data. Given below is the loss and accuracy plot, as you can see in the next slide. And the rest of the results will be discussed by our teammate Bharat.
Hi, now it's time to decide which model is the best one. We have got the accuracies that are 59 for CNN model and 37 for LSTM. So from here we choose CNN as the better model. As my teammate Vaishnavi said, CNN models are widely used when you give the inputs as images, and we use LSTM when the input is in the text format. Uh, Now it's time to deploy the CNN model. We have imported this data and then we mounted the drive here. And then we loaded the Keras trained model by having the .h5 file, which we have saved when we finish training the model. And then we load the image and resize it to the required size. After that, create a data generator with the required preprocessing. Then we generate predictions on the new data. Now coming to the results, we have chosen uh, some Indian actors, and he's looking angry on this image, and we got the result here angry. And then he's looking sad here, and we got the result sad here. He is one of the famous Indian cricketer, and he's laughing here, and he's looking happy. We got the result happy here. And he is one of the South Indian actor, is surprising, and we got the result surprise here. Thank you.